Alright guys, so we're going to go and finish up the lesson for this slide. I'm starting here, which is slide, I believe it's slide 4. It's showing 5 on mine, but it's going to be slide 4. And if you guys did your first entry, again, I'm not sharing that with anybody, so you guys can go all out in a form of a poem, just about somebody that you love, that you truly care about. And the reason why I had you all do that is because we're talking about chemical formulas, and one of the chemical formulas that we produce as people when we feel love is this huge molecule. So this huge molecule is the feeling of love, and so it involves dopamine, serotonin, and oxytocin. I highly recommend that you guys research these, just so that you guys can have a better idea of like what they are, but it's not mandatory. And if we look at the chemical formulas, these right here is dopamine, and we can see the element carbon, hydrogen, nitrogen, oxygen. These numbers right here are called subscripts. That number tells us how many carbon atoms are in this chemical formula, how many hydrogens, and if we see here, nitrogen does not have a number, but we can assume, and we will say that it has one nitrogen because the N is there. That doesn't mean that this means that we don't have to put a subscript number because there's only one. Now, if there was two, like oxygen, that's when we put the number 2. So I'm going to go ahead and move on to the next slide. So what we know, atoms are the building blocks of life, but how does it work and how does it look? So I'm going to go back to this slide, where the chemical formula for love is, and if we can see, the atoms that we're talking about are the elements: hydrogen, nitrogen, oxygen, and those building blocks, when you put them together, build awesome chemicals in our bodies, outside our bodies, like in nature, all around us. And that's what we're going to be talking about today, and what we've been talking about today. So here, chemical formulas, like we said before, they are atoms coming together to build certain things. So like baking soda. Baking soda involves sodium, hydrogen, carbon, and oxygen. And if we're looking at the chemical formula, there's only one sodium, one hydrogen, one carbon, and there's 3 oxygen. And then washing soda, which is like the laundry soap, right? That involves sodium, and if we see here, there's 2 sodiums in this formula. There's 1 carbon and 3 oxygens. And we can see with vinegar, the same thing. The formula, it has 1 carbon, 3 hydrogens, 1 carbon, oxygen, oxygen, hydrogen. Now you might be asking, why didn't they just put this carbon with this and then put a 2 in front of it? This is just a way also to write formulas for another reason that we'll get into in a few days. But for now, I just want you all to focus on the subscripts. And if we move to this slide, we went over water. And if we're looking at water, this is a chemical formula for water. There's 2 hydrogens, 1 oxygen. And it's amazing how just these 2 elements create life. It's amazing to know that these 2 elements that we can't even see produce such beautiful things like waterfalls, us, because if it wasn't for water, we wouldn't be here, or any of this, right? So it's amazing to see how these 2 elements, these 2 atoms coming together produce something so vital for life. And if we're looking at the chemical formula, there's 2 hydrogens, and there's a 3D model over here on this side. So the 3D model shows you how hydrogens are this little white ball, and the oxygen is this red one in the middle. And that's that is how we read the chemical formula for H2O, which we know as water. H2O is a chemical formula, but the building blocks or elements we use were hydrogen and oxygen, like we saw in the last slide, right? The elements on the periodic table alone are elements. So if we're looking at the periodic table by itself, when we look at the symbols, those are just the elements. But when they come together, they are called chemical formulas or molecules. So I'm going to go ahead and play this video. Again, if you guys are watching it on your own, just turn off the interactive mode. I'm going to play it.
Interpreting molecular formulas is a skill that is important to chemistry. Molecular formulas show which elements make up the molecule, and they also show us how many of each element are in the molecule. For example, H2O is made up of hydrogen, H, and oxygen, O. A number written to the lower right of an element is a subscript and is the number of atoms in the element.
So I'm going to pause it right here. The subscripts, how many atoms are present. So if we see with H2O, the 2 stands for the 2 hydrogen atoms that are in water.
In this case, hydrogen has a subscript of 2. This means there are 2 atoms of hydrogen present. Oxygen does not have a subscript. This implies there is 1 atom of oxygen. So here we have 1 molecule of water, which has 2 hydrogen atoms and 1 oxygen atom. If we have 2 molecules of H2O, we do not write H2O twice. Instead, a number in front of the molecule tells us how many molecules are present in the formula.
So, the coefficient is the number up front, and that tells us that there's 2 water molecules. There are 2 water molecules. So if we see the 2 up front, how many hydrogen atoms do we have then? We would have 4. So 2 times 2 is 4. And how many oxygens will we have if we're looking at the coefficient? We would have 2. 2 times the 1, that's not written there, but we know that it's only 1, is 2. So in this formula, we can see that there's 4 hydrogens and 2 oxygens. So remember that this one up front is the coefficient. The ones that are at the bottom and are smaller, closer to the elements or to the atom, is the subscript.
This number is called a coefficient. There are 2 molecules, so a coefficient of 2 is placed in front of the molecular formula.
So, in case you didn't get a chance to write down the notes from the video, I went ahead and put it here. The formula shows us which elements make it up and how many elements are present. And we know how many elements are present by the subscripts, shows us how many atoms are present, and coefficients, and that tells us how many molecules are present. So here, what I wanted to show you all was just how we would read, right? So I'm going to use this one, how we would read the formulas. So here is dopamine, serotonin, and oxytocin. Those are the 3 molecules that make up the feeling of love. So if we're looking at the formula here, sorry about that, there was some news that came up. So dopamine, serotonin, and oxytocin are the 3 molecules that make up the larger molecule of love. So if we're looking at this, how many carbon atoms are in dopamine? 8, right? Because we can see the subscript of 8. How many atoms do we see for hydrogen? 11. And now for nitrogen, even though it doesn't have a number, we know that it has 1. And for oxygen, again, we can see the number there, so we know that it has 2 oxygens. So what I want you all to do is just write it out or type it out and tell me how many carbons are in dopamine, how many hydrogens are in dopamine, how many nitrogens, and how many oxygens, and do the same thing for serotonin and oxytocin. So you guys should have been sent to this website. I'm going to go ahead and go to it. I didn't ask you all to do this, but like when we bond, that's what it looks like when two elements bond. We saw the video. I'm going to keep going. If you guys want to read it, please do. So here is some practice that I want you all to do. You can bring up your periodic table so you can know the names of the symbols. There it is right here. So here what it's asking is, so in this column it gives us the name of the chemical formula, and it gives us a chemical formula. And this one is an example that was given to us already. So hydrogen peroxide, I'm going to put hydrogen, because that's the first element that I see in my formula. And it's asking how many numbers of hydrogen. I know that there's 2. So now it's asking what name for element number 2. Element number 2 is oxygen. So here I'm going to put oxygen. Oxygen. And I can see that there are 2. So now what you guys are going to do is you're going to do the rest of them. So press pause here so you can go to the Nearpod and do that. So I went ahead and filled mine out. So now I'm going to submit. Well done. You see, I got them all correct. So I think this is pretty cool because it shows hydrogen peroxide, bleach, rust, aspirin, and rubbing alcohol. So if you want to show off, you can say, oh, can I have some C3H8O, please? And only you will know that it's rubbing alcohol. Just saying. I thought that's pretty cool. So move on to the next slide. That's all you had to do for that one slide. And now here, what I want you all to do is just practice. So from here on out, it's going to be nothing but practice. And what it's asking, write an E for the element or C for compound for each example, right? So here, there's subscripts Fe2O3. So I know that that's a compound, and I'm going to put C. SiO2, also a compound, so I'm going to put C. Zr, I think that is only an element, so I would put E. But I want to make sure, so I'm going to go to my periodic table. And I think it was, wow, I already forgot. It was Zr, right? Zr, so I'm going to go through my periodic table and look for Zr. And here it is, right? Zr. I'm going to attempt to pronounce it zirconium, and it's number 40, right? So I'm going to go back to this. And so I know that it's only an element, so I'm going to put E for element. Fr, I know it's an element, so I'm going to put E for element. Sodium chloride, or NaCl, those are 2 elements coming together, so it is a compound, and I'm going to put C. Number 6, write an example of an element using its name and symbol. So using an element, I'm going to pick an easy one for myself, and I would put oxygen, and I would put the O as its symbol. Write an example of a compound using symbols. Again, I'm going to make it easy on me, and I'm going to go to like number 5. I know it's a compound, and those are the symbols. So I'm going to put NaCl. I know you guys are going to be able to do questions 8 and 9. Just do your best. And if you have any questions, of course, you can message me. Even if it's over the weekend, I will try to respond. Moving on to the next slide. This is again more practice. How many atoms of each element are in each formula? So just like we practiced in the beginning, you're going to do that for 10, 11, 12, 13, and 14 through 17. Again here, more practice. How many hydrogens do you see? How many Li? How many O's? Go ahead and do that. Same thing for this one. Use your knowledge of coefficients to indicate how many of each molecule is shown below. So you're going to go ahead and do that. These down here, like 15, 16, 17, 18, 19, and 20 are going to be a little bit more difficult, but it does give you here what to look for, right? So for N2, I'm going to read the question again. So I'm going to look at number 15. N2 plus 3H2 gives me 2NH3. And we'll learn more about balancing equations later, but use your knowledge of coefficients to indicate how many of each molecule is shown. So here, for N2, I'm only going to look at N2, and I know that there's 2 molecules of nitrogen, right? So I'm going to put 2 there. H2, if we look at the coefficient here, there's 3 there, right? So there's, okay, so for coefficients, going back to number 15, there's N2, the coefficient. There is no coefficient, so I know there's only one N2, so I'm going to put 1 there. There's a coefficient of 3 right here, and it's asking how many of the H2s that I see, so there I know that there's 3. I'm going to put the number 3. And now it's asking for NH3. If I look at the coefficient, there's 2 molecules of NH3, so I'm going to put 2 there. And going to number 11, there is no coefficient, so I know there's only going to be 1 molecule of O2, so I'm going to put 1 there. The coefficient that I see here for H2 is 2, so I'm going to put 2, right? And go ahead and do that for the rest of these. Moving on to the next slide, again, more practice. For each molecule shown, indicate how many atoms of each element can be found. For each reaction, indicate how many atoms of each element can be found on each side of the equation. So oxygen, now we're going to be looking at the subscripts. There's 2, right? So I'm going to put the number 2. I'm looking at the coefficient and the subscript. So 2 times 2 is 4. So I'm going to put 4 right there. Now this one has a coefficient of 4, and oxygen has a subscript of 3. So there's going to be 4 molecules of KClO3. So there's going to be 4 molecules of calcium. So I'm going to put 4, that's sodium, 4 atoms of potassium. So I'm going to put a 4 there. And then it's going to be 4 for chlorine. So I'm going to put 4, and now it's oxygen. 4 times 3, there's going to be 12, so I'm going to put 12 oxygen. And you're going to do that for the rest of these. There is a parentheses here for number 24, and the way this works, so this indicates that this 3 right here at the bottom, you're going to multiply 3 times this 3, and then 3 times 1. So 3 times 3 is 9. So I know here there's going to be 9 oxygens, and there's going to be 3 carbons. So you guys have to write this down. So once we know that there's 9 oxygens, 3 carbons, we also see this coefficient of 2. So now that, again, is doubled. So 2 times 2, 2 times 3 for carbon, and then 2 times 9. And that's going to give us our answer for Al for carbon and for oxygen. If you guys need help on this one, again, just ask me a question, or send me a question over Teams, and I can help you all out. But other than that, do the same thing for the rest of these. And that was it. That was the last practice that you guys had for this lesson. So I really don't want you all to be too confused, so I'm going to go ahead and show you again for this one. So we're going to do 3. Let me make sure I have my pen. So I'm going to edit, draw. And so we're going to go here. 3 times 3 is 9. So now I'm going to have 9. And then 3 times 3 is 3. And then if we look at the subscript, 2 times 3 is 6. So now I'm going to have 6. And 2 times 9 is 18. It's 18. So I'm going to put 18. This one is 6. And then 2 times 2 is 4. And now I have my answer. There's 4 Al atoms, 6 atoms of carbon, and 18 atoms of oxygen.